Hey guys, Ms. Gosling here. In this video, you're going to learn about Newton's first law. By the end of the video, you'll be able to define and give examples of Newton's first law of motion. So let's go ahead and get started. And we're going to start by actually defining a force. So a force is any push or pull on an object. Now, this push or pull can be because I am physically pushing or pulling on an object. So I'm applying a force to an object. It could also be due to the object's contact with a surface. So if an object is sitting on a table, that table is exerting a force on the object. And these are all forces that are spread through physical connection between the thing applying the force and the thing having the force applied to it. However, some of our forces also work over longer distances. So for example, gravity keeps our moon traveling around the Earth, keeps the Earth traveling around the sun, and is something that exists regardless of whether those two bodies are touching. So the moon and the Earth are not touching one another, but are still feeling a force, an attractive force pulling them together. We see similar things in things like electricity, magnetism, and in the nuclei of atoms. We're not going to get into that for a while, though. So now that you know what a force is, let's go ahead and talk about Newton's first law of motion. Now, Sir Isaac Newton, for those of you who don't know who he is one of the fathers of physics, particularly classical mechanics, and his three laws of motion are the underpinning of a lot of our understanding about motion, particularly the motion of large objects. It gets a little funky when we get down to things like the size of electrons. But we're not going to worry about that in this class. So Newton came up with three key laws of motion, and in this video we're going to be talking about the first one. And the first one is known as the law of inertia, or the law of balanced forces. So the law of inertia says that an object in motion stays in motion, and an object at rest stays at rest, unless, and there's our key word here, right guys, unless acted upon by an unbalanced outside force. So let's talk about what this means. So inertia is a quality of an object, quality of mass that resists changes in its motion. So unless I start an object moving, it's not going to move. It's going to stay at rest. And once it's already moving, unless I stop it, the object is again going to continue moving with a constant velocity forever, unless I stop it. So unless I act upon it with an unbalanced outside force. So when I say unbalanced, I mean if I am tugging at the force, or at this bucket, and you are also tugging at the bucket, that bucket's not going to fall over because we are applying balanced forces, equal forces to that bucket. However, if I let go, that bucket's going to topple right over on top of you because now it's unbalanced. So now the law of inertia no longer fits our situation. So again, to summarize, an object will not change its motion unless an unbalanced force acts upon it. So there you go. That is Newton's first law. So one common misconception is that if no forces are acting on an object, that the object will slow down and eventually come to a stop. And the reason that a lot of people think that is because that's what we experience in real life, right? So think about, for example, if I take a hockey puck and I kick it across ice. We don't see any forces acting on that hockey puck, and it does eventually come to a stop, right? It's not going to go across the ice forever. However, there is a force acting on it. Specifically, we have the force of friction acting on our hockey puck, which is what is causing it to stop. So because we've never really experienced a situation without forces acting on objects, because we're on Earth, there's always gravity, there's always air resistance, there's always friction. Because we don't experience a place where there are no forces acting on objects, our instinct is to say that objects will eventually stop. However, in a situation where there really are no external forces acting, the objects really will continue to move forever. So that brings us to our example here. If I go into outer space, far away from any planets, stars, or asteroids, so no gravity, and I throw a baseball. What's going to happen to that baseball? So according to Newton's first law, if there are no forces acting on an object, it's going to continue moving with a constant velocity. So my baseball is going to move at a constant velocity forever, as long as no forces act on it. So until it's caught by an alien or runs into an asteroid, that baseball is going to move at the same velocity forever. And you'll notice I wrote at a constant, and I forgot to write the word velocity, which is our key term here. That's going to be our key word, that constant velocity forever, without any extra forces acting on it. So takeaways. A force is defined as a push or a pull. And Newton's first law says that objects have a tendency to resist changes to their motion. So unless unbalanced outside forces act on our objects, their motion will not change. And there you have it, folks. That is Newton's first law.